In this video, I will show you how to differentiate two functions being multiplied together, a product if you will, also like double brackets. So we are going through all of these three examples and I'm going to break them down. Let's dive into this straight away. For the first one, say you have to differentiate x times x plus 1. All you want to do is just remove the brackets. So the first thing to do is open up, expand the brackets in order to fit it into power rule for derivative, since at this point we are unable to use a power rule. So let's begin. So let's take this x and distribute over the bracket. So it becomes x times x squared plus x times 1 leaves you with x. Now we're ready to use a power rule for derivatives, and it's going to be just a piece of cake. Now, as a quick reminder, a power rule, and all it says that you want to bring your power of x in front as the coefficient, so n jumps out front, and you want to reduce your power by 1, so knock it down, decrease it by 1. Alright, for the first one, we want to bring this 2 in front, so it's gonna be 2x, and we want to reduce the power by 1. So your new power becomes the first, so we don't have to write it explicitly. Moving to the next term. So all you need to remember that the derivative of x is just 1. You could derive it from a power rule, but it's worth to remember as a separate rule. So you are left with 1 instead of the second term. And that's gonna be your final derivative for this one. Lovely. As a quick legal disclaimer, if you are familiar with the product rule, definitely you can use a product rule for derivatives for this one. But my point is to just show you how to use algebra. Alright, let's move to the second one. You are given a double brackets. Precisely the same idea. You want to open and FOIL everything out. So you want to take this x and multiply by both terms in the second brackets, and the same goes for negative 3. So let's start with this. So you will get x times 2x, 2x squared, plus x times 1, which is x, minus 3 times 2x, 6x, and minus 3. Alright, let's simplify a little bit. Let's combine these two like terms, so x and negative 6x. So 2x squared remains the same, so it's gonna be negative 5x minus 3 hanging around. Alright, this is simple quadratic, basic quadratic, and we are going to use power rule. So y prime, the derivative is, so by the power rule it's gonna be 2 times 2, 4, 2 times 2 x minus, so remember the derivative of x is just 1, x goes away, bye-bye. So you end up with just negative 5, remains the same. And the derivative of negative 3 is just 0. Derivative of any constant is just 0. So keep simplifying, it's gonna be 4x minus 5, which is your final derivative. Alright, the last one. So you have 1 minus x squared. So again, the point is to expand this expression. And you could do it differently. You could either think of this as 1 minus x being multiplied by itself, and you want to do the same as we did for number 2. Or you can use a separate formula, a minus b squared, which is a squared, the square of the first term, minus twice a times b, and plus b squared. It's worth to remember. Alright, so ua is 1 and ub is x. We can match up. So it becomes 1 squared, which is 1 minus 2, 1 times x, x, and plus x squared. Perfect. Anyway, you will get this quadratic. So let's move to the next step. So we are ready to differentiate this with respect to x. So dy dx, so you could use y prime notation, is, so derivative of 1 is just 0, 1 goes away, so derivative of x is 1, so you end up getting 2. And for the last one, it's gonna be 2x by a power rule. Now you can leave your answer like this, that's technically fine, perfectly fine. But in order to simplify it even more, we can pull out actually -2, since both terms share this -2 as a common factor. So your final derivative is -2 brackets 1 minus x. Again, both versions are totally fine.